since human beings appeared, they usually carry a lot of confusion. In each corner, there are people looking at the stars wonder about the universe. Why does the sun rise in the east and set in the west? Why does the moon always revolve around the earth? What kind of is the largest celestial body in the universe? What is the magic scenery of the singularity in the black hole? From the gravitational attraction between the celestial bodies to the continuous research for the mysterious existence of black hole, people found out more and learned more. But in the meantime, there are more mysteries waiting to be answered. 100 years ago, the American astronomer, whose name is Halley Shapley, first discovered our Milky Way galaxy, with its center in the direction of Sagittarius. Later, astronomers found a powerful source of radio radiation with long period of observation and named it Sagittarius A star. All stars in the Milky Way are also orbiting around it. 50 years ago, based on the theories of relativity, astronomers suspected that there might be a black hole at the center of our galaxy. After the discovery of quasars in the early 1960s, astronomers upgraded their guesses to extrapolations. They believed supermassive black holes were likely to exist in most large galaxies, including the Milky Way. So numerous astronomers had set out to find more observational evidence for this idea. A team led by Rajajenzo and Angel Jans raced around the star of Sagittarius A star. So how did they find and confirm this black hole? Next, let's follow in the footsteps of astronomers and explore step by step. If we look directly at the optical band of the galaxy center, we can see the star of the galaxy center because of the obscuring dust. So the scientists choose a near-infrared band with a center of about 2.2 micron. This is the optical view of the Milky Way. As we can see, the middle is dark. Continuing with observation in the near-infrared at about 2.2 micron, we can see that the center of the Milky Way galaxy is actually bright. So this solves our visible problem. But the Milky Way center is too far away, and atmospheric jitters don't provide enough spatial resolution to allow our to see more details. This means that we need large telescope and better equipment and technology to improve the spatial resolution of observations. Eventually, German astronomer Rajajenzo and his team moved to the Pyrenees Mountains. 4-meter VLT telescopes were used for observation. A team led by Angel for the US chose the Monarchy in Hawaii. Here is the Kite telescope, the largest optical telescope currently on the ground. It is not enough to have a large aperture telescope because the atmospheric jitters limited the play our telescopes. To this end, scientists are using a more evidenced technology, adaptive optics. Telescope equipped with an adaptive optics system can deform the telescope mirror to minimize the effect of atmospheric jitters. In this way, the telescope will perform as well as it should. We have solved the problem of the visible and see clearly. Then we only need to observe stars around the Sagittarius A stars. We are going to refocus our telescope on Sagittarius A star, and we are going to give it a family photo. Let's start by looking directly at the stars at the center of our near-infrared eyes. Now, let's take a picture of them. But we find that the stars are blurred. Now, let's turn on the adaptive optics system. Obviously, we can see that the stars are gradually becoming clean. Now, we can make observations and measurements of the center of the Milky Way galaxy. In this image taken by Rajajendo's team of the position of the stars around Sagittarius A star, we can see that their positions have changed at different times. But this is only in 2 dimensions. The real trajectory is in 3 dimensions. So, scientists use the Doppler effect to obtain radial motion, which in turn produces a 3-dimensional picture of space. You see, the stars here are in elliptical motion around an invisible point. What does that mean? Just like our solar system, all the planets in the sun's gravity around the sun ellipse. These stars are also in television elliptical motions around some invisible body. From the trajectory and the period of these stars, the mass of the central body around the star can be obtained by calculating the kinematic formula. To their surprise, they found hidden there was a monster object with a mass of more than 4 million suns, but only the size of our solar system. Such a matter of super high mass and density. According to the exciting theoretical interpretation, it seems that it can only be a supermassive black hole. In other words, the observation confirms that the Milky Way has a supermassive black hole at its center. In April 2019, the Event Horizon Telescope captured and published images of the black hole at the center of the galaxy MA7 at radio wavelengths. For the first time in human history, a black hole was witnessed. And on May 12, 2022, the mystery of the galactic central black hole was also revealed. Let us thank all scientific workers, which allows us to see the MA7 and the Milky Way galactic central black hole. Astronomical exploration will never stop.